Okay, so we are talking about finite automata. So far we have discussed the DFA, the deterministic finite automata. So today we will talk about the NFA, non-deterministic finite automata. So for DFA, just to recap, so for DFA we have 5 tuple. This is the set of all states. This is the state set which is finite, and this is the input alphabet. This is also finite set. For binary alphabet, it is 0 and 1, and we have a transition rules, which is a function form, which is taking a state and a alphabet, and it is reaching to another states. And this one is the start state or initial state, starting state, and f is a subset of q, which is some of the states which are called accepting state or the final states. Or accepting state. Okay. So, this delta is so this is the function form. We are taking we are at a state q. We take a delta of q comma a. It is going to a fixed state. So, deterministic way, but in the non-deterministic NFA, there is no fixed state for it. There is a set of state where it can go. So, that we will define, and also in the DFA. So, this is DFA. Also in the DFA, what we define the extended delta hat, which is taking a string q cross to q. So, delta hat, how we are defining delta hat? It is a recursive way. The base case is delta hat of q comma epsilon is q. Epsilon is the no input. So, empty input or no input, and if you take w to be x a, this x is a string, then delta hat of q comma x a is defined as delta of delta hat of q comma x, then the finally we read a. So, that means, so meaning of this is we are at qth state, we want to read this. So, we first read x, and suppose we are going to a pth state, and then from here if it is going to rth state by a. So, this is nothing but w. So, this is the delta hat of w q q w is r. This is the recursive way. Now, then we define the language of a DFA, that is basically L of a, which is nothing but the set of all strings such that it is at the end it is reaching to the final state. So, that means delta hat of q 0 w is belongs to f. So, we start with q, and then we read the string and we change the state each time, and if we can end with a final state. So, then we say that string is accepted by that DFA, and collection of all such acceptance string is called language of the DFA. And we have seen a regular language, a language if there is a DFA which is accepting the language is called regular language. Okay, so these are the DFA, deterministic finite automata. Now we will define what is called NFA, non-deterministic finite automata. Then we talk about their language accepted by NFA. Okay, non-deterministic finite automata. So, it is also a 5 tuple q sigma delta q 0 f. Now, q is same as q is the states, the set of all possible state which are finite, set of possible states. This is a finite set, and this is input alphabet which is also finite. If it is binary, then it is 0 1, but in general it could be any finite set. This will define. So, this is a starting state or the initial state, and this is again subset of Q, which is the set of all final states. There could be one or more final states. Now, let us define this delta. Now, earlier delta was a function form, it is taking a state q. So, delta of q and a, it is taking a input a. Earlier it was going to a fixed state p say. So, delta of q comma a, but here it is not unique, it is not deterministic. Here we have many options, like it can go to state p 1, it can go to state p 2, this is also a move, it can go to state dot 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 p k, this is also move delta of q comma a. So, it is not a deterministic way. So, it is a that is why it is called non-deterministic. Okay. It can go to a any of these states. So, this is a subset of this. So, basically delta of q comma a, here if it is this subset p 1 p 2 p k. So, this is a subset of q. So, it can go to any subset of q. So, the basically delta is here a function, non-deterministic function. Delta is a function which is taking at a state and a alphabet, and it is going to a subset of q. This is called power set. This we can denote as power of q also. This is basically a set of all possible subset of all possible subsets of q, that is called power set. So, it is a so it is a non-deterministic function. So, we can go to any one of these states, I mean this among this subset, I mean. Okay. So, this is the difference between DFA and NFA. The DFA move is deterministic, but the NFA move is non-deterministic. So, among these, I mean it is a collection of, it is a subset where we can move. Now, we can move to any one of these states from this subset. So, that is why it is called non-deterministic. So, we can take an example. So, of a NFA. So, let us take an example of NFA. Okay. So, suppose we have a starting state, this is we have to start, which is same as earlier. Now, from here we can have two inputs. So, suppose sigma is binary 0 1. Okay. Now, from here we can have two input, So, if we have input 0, it is going to if we have input say q 1 q 2. So, if we have input 0, anyway I can follow this. So, q 2, then let me write this first q 2, then we are telling this q 3, then q 4. These are the states. So, q is nothing but q 1 q 2 sorry q 0 q 1 q 2 q 3 q 4. So, there are 5 states in this automata. Okay, now, let us define the moves. So, if we see a 0, we can go here or we can go here, because this now the move is the transition function, it is a subset. So, this subset with from q 1. So, from q 0 we can go either to q 3 with the 0 move, or we can go to q 1 again q 0 again with the 0 move. So, that means delta of q 0 0 is this subset q 0 q 3. So, that is why it is non-deterministic. So, we can go either to we can either at be q 0 or we can move to q 3. Okay. So, now so let us just complete it, and from 1 we can go to here, this is singleton set, it could be again can go to here, I mean there any kind of, this is just an example, and from q 3 we have a move for 0 and there is no move for 1. So, that means for from delta of q 3, if we have a 1, this is empty, because there is no move, empty set, this is empty set, it is not going anywhere, there is no move from q 3 with the input 1. And it is possible, because delta is a function from q cross sigma to 2 to the power q, and phi is also a member of 2 to the power q, phi is the empty set, 2 to the power q is the power set, set of all possible subset, phi is also a subset. So, it is possible to have no move. So, let me complete this. So, now this is 1 and this is, if we have 0 1 and then here also if we have 0 or 1, and we can define some states as a final states. So, these are the, this is one example where these two are. So, what is f? F is, so this is our NFA, NFA is q sigma delta q 0 f. So, this is q and sigma is 0 1, delta we have to define, q 0 is the starting state, this one, and f is this two, q 3 q 2 and q 4. Now, we have to define delta. So, delta function is like this. So, these are the state q 0, q 1, q 2, q 3, q 4, and these are the input 0 and 1. Okay. So, from 0, if you take input 0 from q, so you can just we need some more space over here. You can put 1 over here. So, now suppose we are at this state q 0. Now, if we have a input 0, then we can go to q 3 and q 1. So, this is a subset, sorry, q 0 and q 3. And now, if you see a 1, it is only going to this if it is 1, then it is going to, if we can make it 0 1 again, I am following this example. So, then it is going to q 0 and q 2, sorry q 1, this is q 1, q 0 and q 1 if it is 1. And now, again from q 1, If it is 0, it is empty because there is no move for 0, and if it is 1, it is going to q 2, and from q 2, if it is 0 or 1 both, it is just going to q 2. From q 2, if it is 0 1 both, it is going to q 2, and from q 3, we have a 0 move, it is going to q 4, but we have no move for 1. So, it can be, it is empty. From q 3, we have no move for 1, and from q 4 everything is q 4 again, q 4. Okay. So, this is one example of a NFA, non-deterministic, because here what is the difference between DFA and NFA? Difference is in the DFA we have a deterministic move. If we have q 0, if we have a input 0, there should be a deterministic way that to tell the output where we should go, but here we have two options, we can either go to q 3 or we can be remain at q 0. So, that is the way it is, that is the sense it is called non-deterministic. Okay. So, this is a, that is why it is here delta is a function from q cross sigma to power set of this. So, it is taking, so it is a, so q comma a, this is a subset of q, that is the difference, and earlier it was a single state, but here it could be a many state subset of q. Now, our option is more, we can go to any one of these states. Okay. Now, we will talk about the how we can extend, how we can, this is for single input like for alpha, for A, the input alphabet. Now, we see how we can extend this for say string, how a NFA can execute over a string. So, that we are going to extend this delta hat, that we will define. We will come back to this example. So, we are going to extend this delta hat. So, extend the extended transition function. That is called delta hat for NFA. We know how we could extend this for DFA, but here we are talking about NFA. Okay. So, for NFA, delta is a function from q cross sigma to the power set. Now, we need to have we want to have a function delta hat which is taking a string instead of a single alphabet. It could be single also, yeah, it could be empty also, empty string. Then it should move to the this. Okay. So, we are going to do that. So, this is the similar way we did it for the DFA, but here for DFA we had the single state, but here we have multi state. So, this is the base case. So, we define the delta hat of q comma epsilon is q. That means, if we are at q and if we have no move, no input, we will be remain at q, that is the idea. This is means no move. If we are at q, we will be remain at q. I mean with the epsilon move, we can say epsilon means move means we are not reading any string. We are not reading, there is no input alphabet in the tape. So, there will be no move, but we will after this NFA we will talk about epsilon NFA, there we are allowed to take the epsilon move. I mean no input, still we can move to some states. Anyway, that will come at later stage, but for the time being this is the convention. And the second one, suppose this is x a. So, we take a string w is say some x 1, x 2, x k a. So, this is we are say x a x. So, w is coming from sigma star. So, it is either this or it has some alphabets. So, now how we define this on this? So, first we execute this inductive process. I mean, so first we execute delta hat on q on x. So, this is earlier for DFE it was a singleton state, but it is a now this could be a many state. Suppose this is P 1, P 2, P k, and then from there we take a move, we take a input A, and it can go to again multi states from that state. So, that is our W of this. So, let us just complete this, and suppose we know this delta of P I comma A. So, A is the last symbol. Suppose this is some R I. So, R I 1, R I 2, R I L. So, this is called or R I M. So, this we denote by this. Now, so this is for I is equal to 1 to k. So, for each of these states we will be able to go to many other states. So, like this. So, this is our q. Now, we want to read this. So, we first read x. So, for by x it can go to many states like P 1, P 2 dot 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 P k, P k. So, these are all delta hat of q comma x, delta hat of q comma x, delta hat of q comma x. So, this is the possible state after reading the string x. Now, from each of these we are going to read A now. So, now again delta hat of P 1 A. So, this is NFA. So, this is again a subset. So, if that subset is R 1, R 2, R L say. So, from here we can go to this R 1, R 2 like this, R 1 1, R 1 2 like this, R 1 L. Okay. And again from P 2 we can go to some other states, say S 1, S 2 1, S 2 2 like this. So, these are the sets. From again P k we go to many other states. So, these are the sets which is basically delta hat of q comma x a. So, it is nothing but the union of delta of P I comma A, where I is from 1 to k. And what is P I? P I mean delta hat of q comma x is nothing but this P i's, P 1, P 2, P k. So, this is the P 1, P 2, P k. Okay. So, this is the way how we define this. So, to compute delta hat of x a w, we first compute delta hat of q x, and then from those state we just directly take the input a and we will go to many other states. So, that collection, that union will be the delta hat of q comma w. So, w is our, this is our w. So, this is the way, the inductive way, recursive way we define this. Okay. So, now if we can take one example on this. So, that we will be discussing in the next class. Thank you.